1 is really about linear equations and inequalities. So this is a lot of review, so this should be fairly easy for you. So we're going to start off with the basics, because if we don't all use the same vocabulary, then we can't get anywhere. So the first vocabulary is an equation. What is an equation? Well, it's just a statement that two expressions are equal. And then what do we mean by a variable? Well, it's the unknown value. And usually when we're talking about equations, the solution is the value that makes the equation true. Now, the first types of equations we're going to be looking at are linear equations. And that just means that we have linear equation in one variable. That just means the variable is to the first degree, In other words, I don't have any x squareds or anything weird going on. It's just simple equations. So we are going into solving linear equations, and we're going to have to review a lot, because most people look at the fractions and go, oh no, I don't know what to do. So I'm also going to be showing y'all some tricks, I guess, to make solving equations easier, because we can use those later on too. Okay, so on the first equation, notice that we have fractions, and everybody hates fractions, I know. So there's a trick to getting rid of the fractions. I need to multiply by the least common denominator. So a denominator that both of these numbers could become by multiplication. So if we remember from previous courses, if I have a third and a fourth, the least common denominator would be 12. 3 times 4 is 12. And that's usually the easiest way to find it. Just multiply them together. And I'm going to multiply both sides of the equation, because remember, to keep things balanced in an equation, what you do to one side, you must do to the other. And now we're just going to distribute. So, especially in these first few ones, I'm not going to skip a lot of steps, but I will talk about some things like when I multiply 12 times something over 4, I can divide that 12 by the 4. So 4 goes into 12 3 times. And then I have 3 times 3 is 9x. Then 12 times 3 is 36. Over here, I have a 3 in the denominator. 12 divided by 3 would be a 4. And now I'm going to multiply that times the numerator. Now, if you don't believe me on that little trick, let me show you again on this 12 times 3/4, 3x over 4. So if I did 12, make that into a fraction, times 3x over 4. If you do it the long way, 12 times 3 is 36 over 4, and then divide 36 divided by 4 is 9x. So notice we got the same answer, but this is a little bit quicker. So the quickness is to go 4 into 12 leaves me a 3. 3 times 3 is 9. Okay, so I get 9x plus 36 equals, distribute. And now we want to get all our variables on one side and all of our non-variables, constants, on the other side. So I'm going to subtract the 4x from each side. That's going to put all my x's on the left side. Well, that means I want all my constants on the right side. So I'm going to subtract 36 from each side. Now, as we go through the course, I may not be showing every single little step like this, but just to start off, I will. So that's going to be negative 40. Then we divide by 5. Or what you're doing to one side, you have to do to the other side. And we can always double check that this is the correct solution by plugging it back in. All right, next one. Let me fix my camera a little bit. There we go. We got 2z, so my variable z, over 3 equals negative 6. So again, this one only has one denominator. It's a 3. So I'm going to multiply both sides by 3. The 3's would cancel, divide out. Negative 6 times 3 is negative 18. This was a lot easier. This should have been number 1. Oh. And we can double check real easy on this one. 2 times negative 9 is negative 18 divided by 3. Yep. So what would I multiply this equation by? Well, 2 and a 3, that gives me a 6. So I'm going to multiply both sides of the equation by 6. 2 goes into 6 3 times, but I'm going to have to multiply that 3 times all of that numerator. Over here, this is going to have to distribute. So 3 goes into 6 2 times. 2 times x is 2x. Minus 6 times 3 is 18. I distributed the 3. Now we want to combine like terms. So that would give me 7x equals negative 21. Subtract the 2x. Subtract the 3. X equals negative 3. All right. Now, this course is about applications in the real world. So we will have to take some of these word problems and convert them into equations so that we can solve them. So when we're using an equation to describe or model a set of data, sometimes it's useful to let a variable represent the number of years past a given year. It's called aligning the data. So the U.S. Hispanic population, using data from 1980 and projecting to 2050, the number of Hispanics in the U.S. Civilian non-institutional population is given by this equation in millions, where X is the number of years after 1980. According to this equation, in what year will the population equal 36.74 million? So what is representing, so X is the number of years, and the population is given by Y equals. So this is going to go in for Y. So we would get 36.74 equals 0.876x plus 6.084. And I'm going to have to grab my calculator real fast. And that's another thing, we will be using the calculators a lot throughout this year, so I'll usually have them out on the desks already for you. If you're in class. If you're at home, I highly suggest either getting a graphing calculator or using Desmos. So I'm going to subtract by the 6.084, and that gives me 30.656. And don't be freaked out that we have weird numbers. When we do real life situations, we're going to have weird numbers. Now I'm going to divide by the coefficient of x. And we get 34.995 is x. Well, that's approximately what? That's approximately 35. And we're talking about years, so talking about 0.995 years doesn't make sense. So that's approximately 35 years. And remember, the number of years was after 1980. So we would have to come over and go 1980 plus 35 gives us 2015. So in 2015, the population is approximately 36.74 million. Notice also that when it's a word problem, we want to make sure we actually answer the question. When it was a simple equation, just saying x equals 34.995 would have been fine. But this was a word problem. We needed to ask the question that was given to us. In what year will the population equal 36.74? In 2015, the population is approximately 36.74 million. Okay, the next type of equations are what are called fractional equations. That just means we have a whole bunch of fractions and the variables could be in the denominator. This is also called rational equations. But we're going to use the same technique we used in example 1. We're going to multiply by the least common denominator, which in this case would be 2x plus 10, because let's think about 2x plus 10. 2x plus 10 is the same as 2 times x plus 5. So that's actually a better way to write it. I'm going to rewrite that first one as 2 times x plus 5. Over here, I'm going to leave everything like it was. And now we're going to do the distributing. So here the 2 times x plus 5, or 2x plus 10, would cancel, leaving me with a 3x. Over here, 2 times x plus 5 times 1 would just be 2 parentheses x plus 5, or 2x plus 10. Plus, when I multiply by this second term, the x plus 5s would divide out, and I'd be left with 2 times 1, which is 2. So I would end up subtracting by the 2x and get x equals 12. Now, when we have fractions and the variables are in the denominator, it's actually super important to check our answers. There is something very, very bad that can happen when we have a fraction. We can never divide by 0. Never, ever, ever divide by 0. So I want to make sure that if I plug in 12, I do not get a 0 in the denominator. So I'm just going to double check it real quick. When I plug it into the first one, let's see. So I got 3 times 12 over 2 times 12 plus 10. And then on the other side, that's 1 plus 1 over 12 plus 5. That's going to be 36. 24 plus 10 is 34 equals 1 plus 1 over 17. Well, will it? Let's see. This would be 17 over 17 plus 1 over 17. That's 18 over 17. And those are equivalent. So this is my answer. Okay. What's the least common denominator for the next one? Well, this one's really nice. It gave us x minus 3 and an x minus 3. So my common denominator is just an x minus 3. So when I multiply on the first one, x minus 3's would divide out, leave me with the numerator of 2x minus 1. On the right side, I would distribute x minus 3 times 4, so 4 times x minus 3, plus the x minus 3's would divide out and leave me with a 5 over here. I'm going to distribute the 4. And then, let's see, I'm going to subtract the 4x and get negative 2x over here. That's going to be a negative 11, but then I need to add 1. So that'd be negative, what's that, 10? Negative 12 plus 5 is negative 7. Golly, and then I add the 1. That's a negative 6. Okay. So x equals 3. Let's double check everything. 2 times 3 minus 1 over 3. Over 3 minus 3. That is bad. That means this is a bad answer. It technically has a name. It's called an extraneous solution. It means we got the answer by using correct algebra, but it doesn't work when substituted back in. All right. Now, sometimes with linear equations, we have two variables. We have x's and y's. There's the two variable. That just means we have more than one variable. And so a lot of times this is when we're talking about we have lots of different solutions, a lot of x's and y's that will make this work. That's what gives us a graph, a line. But to be able to do that, we need to be able to solve for y. So let's remember how to solve for y. That means to get y by itself. So we need to move anything else to the other side. So I'm going to subtract 4x from each side. Then I still want to get y by itself, so I'm going to divide both sides by 3 and get y equals negative 4 divided by 3 would be a negative 4/3 x plus 12 divided by 3 is 4. And now it's ready for further work, like graphing it or something like that. Now, I do apologize. My numbering seems to be off on page numbers, so I don't know what happened there. Oh, just ignore them. Okay. All right, so we have two variables in this equation, and this is the relationship between the firm's profit and the number of items sold. So P is profit, X is the number of items sold. How many units must be produced and sold for the firm to make a profit of 150? So profit of 150, that's P. So we're going to plug that in for P. So X equals 360. 360 what? Word problem. Can't just say X equals blah. 360 units give a profit of $150. Okay. Solve this equation for P in terms of X. So it says for P in terms of X, that means we want to get P by itself. Let's block this off. Okay. And if I want to get P by itself, I'm going to move the 5X over. Then divide both sides by the -4. Same techniques as solving for Y. Just we have different variables. It's okay. So a -5 divided by -4 will be +5/4. Then 1,200 divided by 4 is going to give me a -300. Now, since this was not associated like with a word problem question, we don't have to make sure our units are there or anything. Find the profit when 240 units are sold. And notice by rearranging this equation, it's a lot easier to find the profit given the number of units. All I have to do is plug in X and simplify. So here's where that trick comes in handy. 240 divided by 4 is 60. 60 times 5 is 300. So what does that mean? Profit of 0? We have a profit of $0 when 240 units are sold. But what does that mean? The firm breaks even. And sometimes we want to know when a firm is going to break even. You don't want to be not making a profit, but at least you want to break even. 0 profit just means that you're spending exactly what you're bringing in. So that's going to be a key point that comes up throughout the course. We want to know when a company breaks even. All right. Now, there's some guidelines when we're doing these word problems if they don't give us the equation. So the last couple of them, they gave us the equation. The first thing is read the problem carefully. Determine what you're supposed to find. Use a variable to represent what you're trying to find. Reread the problem and use your variables to translate what's given to you into algebra. Sometimes a figure can help. And then we'll use that expression to make an equation. In other words, there's going to be an equal sign. And then we'll solve it. Check the solution in the problem. It must make sense. It must work. So you'll definitely want to check your answers. Okay, so this is an investment type question. And Jill has $90,000 to invest. She has chosen a relatively safe investment fund that has an annual yield of 10% and a riskier one that has a 15% yield. How much should she invest in each fund if she would like to earn $10,000 in 1 year? So let's kind of break this down. I'm gonna kind of make a little table here. So we're gonna have amount invested. We're gonna have the rate, and we need to think about we're trying to earn some money from these values, and that's called the interest earned. Okay, so let's just break this down. So the amount that she's investing, if she invests, let's say X is the one that she's investing at the 10%. So that I'm going to change that to 0.10, 10%. 10% is 0.10. 15% would be 0.15. So X is the amount invested at 10%. If she has $90,000 to invest, then to the other rate, it would be $90,000 minus what she already invested at the other group. Now the interest that's being earned, if she's got X invested at 10%, she's going to earn 0.10 times that X. Now, if it was in there for more than 1 year, we would multiply that by the number of years, but it's just 1 year. 15% is for the rest of the money, so 90,000 minus X. And she wants these two to total up to be 10,000. So we are going to literally take this plus this and set it equal to 10,000. Now we'll distribute. 0.15 times 90,000 is 13,500 minus 0.15x. And my printer just started printing, so ignore that in the background. Now notice this was on the other side of the equal sign, so I had to subtract it from both sides. These are on the same side, so we just combine like terms and get negative 0.05x. See, 10,000 minus 13,500 leaves me with 3,000, negative 3,500. And this is negative, so that makes sense. I don't know what is up with my printer right now. So I'm going to take negative 3,500 divided by negative 0.05, and I get 70,000. So now we have to answer the question, how much should she invest in each fund? Okay, let's try to stop my printer. All right, so if we're answering the question, she's going to invest $70,000 at 10%. And how much money is going to go in the other account? 20,000 at 15%. How do I know it's going to be 70,000 and 20,000? Because they have to add up to be that original 90,000 she invested. All right. The last little bit is talking about inequalities. That just means that we don't have an equal sign. We have less than or greater than. You could also have less than or equal to, greater than or equal to, but they're just not equal. There's an imbalance in the problem. So let's just review solving those. Okay, 2x minus 4 is greater than x plus 6. So we subtract the x, then add the 6. Now, this means that it's not just one value of x, it's all the x's that are greater than 10. So on a number line, it doesn't include 10, but it doesn't start at 11 either, because there's numbers between 10 and 11. There's 10.5, there's 10.1, there's 10.000001. So we would put an open circle and then shade to the right for greater than. Okay, next one. Let's see. I'm going to subtract 2x from each side and get 1 is less than 3x minus 2. Add the 2, I get 3 is less than, oh, that wouldn't be a 3 anymore, would it? If I subtract 2x from 3x, I'd have 1x. Silly rabbit. 3 is less than x. In other words, x is greater than 3. Now, you could have done this one a little bit differently. I just want to remind you. If you had instead subtracted 3x from each side, you would have had negative x, then subtract the 1. Then you would have to divide both sides by negative 1. When you divide by or multiply each side by a negative, your symbol flips. So you would end up with x is greater than 3, which is what we got here. And on the number line, that means we don't include 3, and we're going greater. Okay. Next one, I'm going to distribute the, well, first off, no, I don't want to distribute the 2. I want to get rid of those fractions. So I'm going to multiply both sides by 3. That would give me a 3 times 2 that I need to distribute. So that would be 6x minus 6 times 4 is 24. Over here, the 3's would cancel and end up with 5x is less than, I would add the 24, which would make that a, what does that make that? A 21. X is less than 21/5. You could put the decimal version, that'd be fine, but not necessary. Not equal to, so it's an open circle, and we're going to the left. 3x minus 2 is less than or equal to 7. So 3x is less than or equal to 9. X is less than or equal to 3. This one is an or equal to. So just a reminder, we would have a closed circle, and we'd be going to the left. Last example for today. For boys aged 4 and 16, between 4 and 16, height and age are linearly related. That relation can be expressed with this equation. H is the height, A is the age. To account for natural variation among individuals, normal is considered to be any measure falling within plus or minus 5% of the height obtained from the equation. Write an inequality for the range of normal height for a boy who is 9 years old. So first off, let's figure out what the height would be for someone 9 years old. Let's see, 2.31 times 9 plus 31.26. I'm doing the whole thing in the calculator. Gives me 52.05 inches. Now this plus or minus 5%. Let's talk about that. If I'm increasing or decreasing by 5%. So the lower boundary would be subtracting the 5%. And the upper boundary would be if I added 5%. And my true height would be between those values. Now, could it be equal to those? Sure. But those would be how I found the boundaries. So down here I got 49.4475. And then the other one, the upper boundary for the height would be 54.6525.